Hello, today we're going to look at Bernoulli trials. Our learning outcomes for today are to learn the characteristics of a Bernoulli trial, use these characteristics to identify a Bernoulli trial, learn that the outcomes of a Bernoulli trial, that is the probabilities that you get by calculating a Bernoulli trial, are the same as the terms of the binomial theorem. Okay, you're going to review evaluating the coefficients of the binomial theorem, and you're going to apply this knowledge to calculate the probabilities. So what is a Bernoulli trial? The characteristics of a Bernoulli trial is that there's a finite number of trials. So you pick how many times, so you're going to toss a coin 4 times, or you're going to throw a dice 15 times. So that's a finite number. There's a definite number of trials. 2 possible outcomes. So throwing a coin, it's either going to be a head or a tail. Rolling a dice, it's either going to be the number you want or not going to be the number you want. The probabilities don't change from one trial to the next. So that means that every time you throw a coin, it's always going to be a half, probability of a half that you get a head, or the probability of a half that you get a tail. And every time you roll a dice, the probability of getting a 3 is 1 over 6, and the probability of not getting a 3 is 5 over 6. And each trial is independent. That means the outcome from one result doesn't dictate what happens on the next one. So if you toss a coin, that has no effect on what's going to happen the next time you toss a coin. Or if you roll a dice, doesn't matter what you get, the probabilities for the next time are going to be the same. So I'm going to use some letters here just because they're normally used. So the letters used are things like P, which is what we give the probability of success. And by success, what we mean is getting the outcome we want. Okay, the probability of failure is the opposite of it. And to get that probability, it's 1 minus the probability of success. Then N is your total number of trials. So that's how many times you throw your dice, how many times you toss your coin, etc. And R is the total number of successful outcomes. So if you want to get a head 3 times, when you toss a coin 10 times, well, that would be your R would be 3. So you put them together in this, which is your binomial, your terms of your binomial theorem, and that's N choose R. So the probability of getting R outcomes from N trials is the successful probability to the power of the number of times you want it, multiplied by the unsuccessful, and then you take away those 2 numbers, and that's your power there. You don't have to remember this. This is on page 33 of your tables and formula book here. Okay, so the binomial distribution there. Now, here's our first example. So a couple has 6 children. Find the probability that they have 4 girls and 2 boys. First thing you need to do is check, is it a binomial or Bernoulli trial? So, are there a finite number of trials? Yes, they have 6 children. Is each trial independent? Well, yes, because the gender of one child does not have any effect on the gender of the next trial. Are there only 2 outcomes? Yes, it can be a girl or a boy. And do the probabilities remain the same for each trial? Yes, they're always going to be the same. So if you can answer yes to all of these, it's a Bernoulli trial. If any of these criteria are missing, it's not a Bernoulli trial. So let's see. If we're going to let P equal the probability of having a girl, well then P is a half. Then if you let Q equal the probability of having a boy, then Q is a half as well. Then our total number of trials is 6, because they have 6 children. And the probability that they have 4 girls means that R is 4. So we put that into our formula that we had up above here, this one here. What we get is 6 choose 4 multiplied by a half to the power of 4 multiplied by a half to the power of 2. And when you put that into your calculator, you get 15 over 64. Okay, so looking at our second example, you have 1 in 10 people are left-footed, 11 footballers are picked at random. Find the probability that less than 2 will be left-footed. So, first things first, is it a Bernoulli trial? Is it finite? Yes, there are only 11 footballers picked. Are the trials independent? So in other words, when you pick one person, is the probability, is it affected by your previous picks? If you're going to pick them randomly, yes, it is independent. And no, they're not affected by one. Each outcome is equally likely. Are there two outcomes only? Yes, people are either left-footed or not left-footed. And does the probability change from one trial to another? No, because the probability of each time is that 1 in 10 is left-footed and 9 over 10 is not left-footed. So let's look at the question again. Find the probability that less than 2 will be left-footed. If you write that in English, what it actually means, our probabilities that we're looking for, means that we want the probability that one person is left-footed or the probability that no one is left-footed. So if we're looking at the probability that one person is left-footed, the probability of being left-footed is 1 over 10. The probability of not being left-footed is 9 over 10. There are 10 picks, so that means there are 10 trials, and the successful outcome would be having one of those people left-footed. So that becomes 11 choose 1 times 1 over 10 to the power of 1 times 9 over 10 to the power of 10. Or translates to plus, and then the probability here, it's still 1 over 10, and Q is still 9 over 10, N is still 11, but this time our OR is 0. So that becomes 11 choose 0 times 1 over 10 to the power of 0 times 9 over 10 to the power of 11. You can put that all into the calculator exactly as it's written. Just be careful about putting it in correctly. And you will get 0.697 as your answer. If you want to change that to a percentage, that's 69.7% or 70%. Now when you've gone over those questions, can you go down to the exercise please and do questions 1 to 5. Thank you.